All right, so next up, we're going to touch on reaction mechanisms. And so reaction mechanisms show us how the reaction occurs. And you can think about why we want to learn this. Same way, if you want to fix a car, make it better, you want to first learn how it works. Same with chemical reactions. If we want to make them work better, we first need to understand how they work. And so it's important to note that we're just talking about what we kind of call like regular chemistry. I'll put that in kind of quotes. And so basically what we're talking about here is non-nuclear chemistry. So in the vast majority of chemistry, all we're seeing is the movement of electrons. Right, so there's no change in what the element is. If you have a hydrogen in the beginning, you're going to have a hydrogen in the end. So the elements don't change. All we're changing is the electronic structure around them. What bonds are formed, what bonds are broken, that kind of thing. And so the way we show these mechanisms are with arrows. So we show the flow of electrons with arrows. And so a couple things about these arrows. These arrows always need to start at electrons because they're showing where the electrons are going. So the arrows always start at electrons. And these electrons can be in lone pairs most times, but also in bonds as well. And then finally, these arrows end where the electrons are going. And so most of the time they end at atoms that they're forming bonds to, although they do sometimes end on bonds as well. We won't see that too much. And then the final thing to keep in mind is while we're drawing these mechanisms, don't break any of the Lewis rules. Right, mainly what we're talking about here is the octet rule and the duet rule for hydrogen, right? So hydrogen can't have more than 2 electrons, and most other elements can't have more than 8. So don't break that rule. And then finally, what we're showing here is the movement of electrons. And so since electrons are moving, our charges are going to change. And so if we think about what things are going to gain electrons, remember that electrons are negatively charged. And so as they gain electrons, they'll go from a positive charge back to a neutral charge. And then if they gain more electrons, they'll go to a negative charge. And then vice versa, if they lose electrons, they're losing negative charge. So they're going to get more positive, right? So they're going to go from 0 or -1 to 0, or from 0 to +1. We generally don't go above or below plus or -1. So let's take a generic example. So in this case, we have A-, which does have a lone pair. If you have a negative sign, you can assume that it has a lone pair and you don't have to draw the lone pair. And then we have B+. And so we're going to form a bond between A and B to form our AB product. And so the way we would show that is the electrons are going to start at the electrons of A and then attack B to form this AB bond. You can see that the electrons in this bond originally came from the lone pair of A. Since A was negative and it lost electrons to form this bond, it goes to being neutral. Since B was positive and gained electrons from this bond, it goes to being neutral as well. But it doesn't always have to be totally neutral. You can have a neutral A interacting with a B positive. Again, we can still form this bond. But now A has lost electrons. It was neutral. So now it's going to go from a 0 to a +1 charge. B was positive, has gained electrons, is now just neutral B. So we'll take a look at some more examples later on, but just get the basics down.